anything at all, this identities still hold. Okay? All right. By the way, what happens? What you should think about what happens when you write theta minus pi instead of theta plus pi. Okay, I'll let you think about that, and if you have questions on that, I'll answer that later. Everybody is okay. You guys are feeling okay with these trig functions?
Yeah.
Okay. Now, some special values of these functions. So I want to know what are the values of the trig functions at pi over 4, which we already found. But how about 3 pi over 4, 5 pi over 4, at multiples of pi over 4? Okay. So here's some other special values of the trig functions. Now notice that I have been talking about only sine and cosine, right? And why have I not talked about the other ones yet? Well, yeah, the secant and cosecant, they are just the reciprocals of sine. So once I have a definition for cosine and sine, I have definitions for secant, cosecant, and also for tangent, right? Tangent is just the ratio of sine and cosine. Cotangent would be the ratio of cosine and sine. Okay, so that's why I haven't been talking about them. They have the same definition as before. Okay. All right. So here's oh yeah, this is what I wanted to do. I want to let's say this is my x-axis. Let's say this is my y-axis. Okay, so x-axis, y-axis, this is a unit circle, okay? This is a unit circle. 45 degrees. Let me try to make a 45 degree angle here. Does that seem like about 45? I'll say it's 45, okay. So let's say this is this is P. What are the coordinates of P? Can someone tell me the coordinates of P? This is a 45 degree angle, okay? Pi over 4. Remember, pi over 4 is 45, right? 90 is pi over 2, right? So 45 would be pi over 4. We saw 90 was pi over 2 radians, so this would be 45 degrees. What are the coordinates of P? The coordinates of P are cosine pi over 4 and sine pi over 4, right? Yeah, so this is root 2 over 2. Because we found cosine 45 and sine 45 before, right? Cosine 45, remember we drew a 45, 45, 90 triangle. We found out cosine 45 was root 2 over 2. Sine 45 was root 2 over 2. So the point P has coordinates root 2 over 2 and root 2 over 2, because we know that the first coordinate of P is cosine, second coordinate of P is sine, right? Okay. So how about 3 pi over 4? What are the... So what I want to know is the following. Let's say I ask you this. What's the value of cosine 3 pi over 4? How would you get that? Well, notice 3 pi over 4 is basically the opposite of this point, okay? If I look at directly opposite of this point, P, let's say I get the other point, which is the reflection of the point P across from y-axis, then the angle here, that angle here is 3 pi over 4, right? And so what are the coordinates of this point here? negative root 2 over 2 and positive root 2 over 2, because the height did not change, right? I went directly across the y-axis, okay, and so the coordinates are given by this. So what is cosine of 3 pi over 4? Yeah. Oh, because what I said is that from the point P, right, I am going directly across horizontally, directly across the y-axis. I hit this point, and what happens is that the angle that I have here, that's 3 pi over 4. This angle. Okay, because this is 45, 45, 45, 45. You have a circle, you make 45, 45, 45. Okay, so in other words, remember the circle, you can think of this in the following way. The circle is a symmetric curve, right? It's symmetric about the y-axis. So if I have a point here, if I have a point xy here, what's the opposite point here? So this is what I'm saying. Let me use here. So if I have a circle centered at the origin, right? It is a symmetric curve, right? The the right side is a reflection of the left side, right? So if I have a point here, it is x and y, right? If I go to the opposite, what are the coordinates here? Negative x and y, because it's the reflection of this point, right? The circle is symmetric about the y-axis, right? So for any point you have here, you have another point directly across at the same distance, right? Is that making sense? Is everybody okay with that? All right, because the circle is symmetric. So I have this. And how about 5 pi over 4? Anyone knows the location of 5 pi over 4? Well, 5 pi over 4 would be pi plus pi over 4, right? So it would be directly across like this, right? I have a bad picture there, but this is 5 pi over 4. 5 pi over 4 is basically pi plus pi over 4, right? Pi plus pi over 4. What are the coordinates here? Yeah, both of them are negative, right? The negative root 2 over 2, negative root 2 over 2. And finally, another one I'm going to draw here. Oops. This guy has coordinates what? Root 2 over 2, negative root 2 over 2, right? What is this angle here? 7 pi over 4. Which is 2 pi minus pi over 4, right? 2 pi minus, this is 2 pi minus pi over 4. Is everybody okay with that? So now, if I ask you, hey, what is cosine of 7 pi over 4, what did you say? And the sine 7 pi over 4 would be negative root 2 over 2. Is everybody okay with that? Now, what I did here, you could do the same thing for 30 degrees and 60 degrees as well. Okay, the same thing works. So I won't go over that, but so in your exercises you'll be asked what is the value of cosine theta at 11 pi over 6, for example. Okay, so let me do that example. Let's say I want to find what, the value of cosine at 11 pi over 6. So what I'm going to do is I'm going to look at 11 pi over 6, 11 pi over 6, and I know that 11 pi over 6 is what? Can I say it is, yeah, so this is, can I say this is pi plus, or in other words, I can also say this is, let me write it in a different way. Can I say this is 2 pi minus pi over 6. Okay. So what is cosine of that then? What is cosine of 11 pi over 6? That's the same as cosine of 2 pi minus pi over 6. But remember, whenever you add 2 pi, right? Whenever you add 2 pi, cosine will be what? Same as negative pi over 6, right? Because if you add 2 pi to it, you are coming back to the same terminal side, right? Negative pi over 6 and negative pi over 6 plus 2 pi. They are coterminal, yeah.
I don't understand why you change from 11 pi over 6 to 2 pi minus pi.
Oh, okay. 11 pi. So what I try to do is, in the numerator, I'm trying to write the numerator as a multiple of 6 plus or minus something. Okay. So notice that 11 pi, I can say this is 12 pi minus pi. So I'm looking at the closest multiple of 6. Okay. And then when you divide that by, divide that by 6, you get 2 pi minus pi over 6. Is that making sense? Okay. You guys agree with what I wrote the last line? Okay. What is cosine of negative pi over 6? First of all, can I say that this is the same as cosine pi over 6? I can. Here's why. Let me tell you why. Generally speaking, let me draw a circle again. So those are my x and y axis. Let's say I have the angle theta, which is this angle here. Can someone see what is the angle negative theta? The negative theta would be this, right? So if I join these 2 points, right, the point P has, let's say, coordinates x and y. What are the coordinates of this guy? Yeah, it's a reflection, right? It's a reflection of that point. So then, what is cosine of negative theta? What is cosine of negative theta? Same as cosine theta, right? But sine of negative theta is what? Negative sine theta. Okay, these are actually identities that you should know. Is everybody okay? Because you see, sine theta is given by the second coordinate, right? For P, the second coordinate is y. For negative theta, the second coordinate is negative y, right? So they are negative of each other. Okay, but for theta and negative theta, the x coordinates are the same. Okay, so cosine theta would be the same. All right, so I could then say that cosine of negative pi over 6 is cosine of pi over 6, but can someone tell me what is that? Well, we computed that, right? It was what? It was root 3 over 2. By the way, pi over 6 is what? Pi over 6 is 30 degrees, right? Remember, pi is 180, so 180 over 6 is 30. And we know cosine 30 is root 3 over 2, yeah. Remember, cosine 30, we looked at 30, 60, 90 triangle, and we saw that cosine 30 was root 3 over 2. Okay? Yes. You have to remember this. Not for, if you are in the engineering program, you have to take calculus 2. You might have to take calculus 3, I don't know. And everywhere they are going to use trigonometry, and I promise you, no one's going to review trigonometry anymore. Okay?
You need to write the triangle, get the
Yeah. Oh, I'm going to show you how to remember these values in a second, okay? So you need to know this identities and this these tricks of evaluating these values. I think in your homework there are some problems like this, right? Evaluate these special values. And when they say evaluate, they don't mean use your calculator, okay? They mean find the exact value, okay? Okay. I gave you a handout, right? And in the handout, there is a cheat sheet where you have all the identities that you need to know about trigonometry involving the trig functions. And then there is another page with a circle, right? And it has, it's a unit circle with all the special points labeled, right? You got a copy of that, the circle? You see? So if you have that in front of you, you pretty much know how to find the values of. So in that picture, what you have is that all the angles which are multiples of pi over 4, all the angles which are multiples of pi over 3, all the angles which are multiples of pi over 6. So these are multiples of 45, 30, and 60. Okay? And these are the values that you are required to know. Does it mean that you have to memorize all the coordinates on the circle that I labeled in the handout? The answer is no. Here's one way to remember. You realize that once you know the value of sine and cosine at 0, 30, 45, 60, and 90, you can find the values of cosine and sine at other angles which are multiples of these angles, right? Because you just use the symmetry that way I did. For example, if you know pi over 4, you know the value at 3 pi over 4 because it is the reflection of the point you get for pi over 4 across from the y-axis. So use the symmetry, okay? So what I'm going to tell you is that you need to memorize the values of sine and cosine at angles 0, 30, 60, and 45, and the other ones you can obtain by using symmetry. Am I making sense? So here's what you need to remember. Here's, let's say, a unit circle. And let's say here is the x-axis, and here is the y-axis. I'm going to make a couple of angles here. Let's say this is this about half? Let's say this is about half, even if it is not. So this would be pi over 4, right? And then I need pi over 3, pi over 6, which would be 30 degrees, right? So let's say this is let's say pi over 6. I know it might be a bad scale, but that's okay. And then this would be pi over 6, pi over 3, which would be pi over 3 is 60 degrees, right? Pi over 3. Okay, so what I want to know, what are the coordinates of the points, right? So if I know the coordinates of each point here, so this is 30 here, this is 45. I have really bad scale here, but okay, that's fine. This is this would be 60 degrees, and this would be 90 degrees here. I want to know the coordinates of this point, right? If I know the coordinates of this point, then I know the values of sine and cosine at these angles, right? Well, two of them are pretty easy, right? One of them is 1, 0, right? The other one is 0, 1. Now, how do I remember the coordinates of the other 3 points? Here's the trick. They all have coordinates, so I'm going to keep spaces for them. So this would be the coordinate for this one. For this one, I'll have coordinates here. For this one, I'll have coordinates as well. So I'm going to put commas here. Here's each one of them would be a ratio, right? Each one of them will be a ratio. And each one of them you'll be dividing by 2, okay? You'll be dividing by 2. Okay, now what goes into the numerator? So they all have they are all fractions. They all have the same denominator too, okay? Now, what goes into the numerator? So it'll be 1, 2, 3, and then you go back 1, 2, 3, and then you take square root of everything, okay? Am I making sense?
Yeah.
All right, so you take square roots now. And you take, if you take the square root now, you realize that in the when you take the square roots here, square root of 1 is 1, right?
Yeah.
So this would be root of 3, this would be root 2, this would be root 3, okay? You don't take the root, yeah.
But when you think that the
Yeah. Hypotenuse is what?
is always one.
Yeah. Go ahead.
Square root of 3 and not square root of 3 over 2. And then,
The square root of 3 would be which one?
well, if this is 1, and that's square root of 3 would be square root of 3 over 1.
This is 30 degrees angle.
Yeah.
So here the x coordinate would be root 3 over 2. The y coordinate would be half. For this one, this is 45 degrees. So this is root 2 over 2, root 2 over 2, right? Sine and cosine are both the same, right? Yeah. And the third one is 60 degrees. And we know for 60 degrees, cosine 60 is half, sine 60 is root 3 over 2, right? You guys realize that? Okay, and again, this is a unit circle. And again, my angles, there are some bad scaling here, but if you are okay with that, the rest is okay. All right, this is one way to remember the values. Again, you have all the coordinates, they are fractions, they are all divided by 2. In the numerator, you start with 1, 2, 3, go back 1, 2, 3, and then you take the root of the square root of the numerators. Okay? So, what I would do is I'm going to, before I start the exam, I'm going to write down this in front of me, and then if I need to use it, I can use it. So, for example, now if you want to know, hey, what's the value of cosine of 7 pi over 6, right? How would you find that? Well, what is 7 pi over 6? What's the location of 7 pi over 6? 7 pi over 6 is pi plus pi over 6, right? So the location of 7 pi over 6 would be opposite of pi over 6 like this, right? You realize that? So this would be 7 pi over 6. And then what are the coordinates of this guy? Well, it's the opposite of that, right? So it'll be negative of that, right? So that's how you can find the values of cosine and sine at other multiples of pi over 6. Is everybody okay? So remember this and then use symmetry for others. Yeah. Okay. So, all right. So let's, well, we are not done yet. Maybe it's a good time to take a break. I think for the rest of the class, we still have to do trigonometry. The reason is we need to talk about the trig identities, right? You know that you cannot do trigonometry without talking about the identities, right? So sine squared plus cosine squared is 1. Secant squared is 1 plus tangent squared, and so on. So we'll see those after the break, okay? So coming soon after the break, all the identities. Okay?
Right back after this.
Yeah, sorry, I was just overcomplicating it for
the year. Okay, so I got this identities here. All I want to mention here is that all you need to prove is the first one, and the rest will follow from that one. Okay. Again, well, we don't have to worry about how these are proved. All you need to know, these are the formulas that I can use, okay? So I'm not going to go over the proofs here. So these are called the sum and difference formulas, okay? Now we also need to know the double angle formula, so which is if I have sine of twice an angle, that's the same as 2 times sine theta cosine theta. Okay, if I have an 2 theta, then I can write it in this way. Also, cosine of 2 theta is cosine squared theta minus sine squared theta. Okay. So these are called the double angle identities. There are 2 others that we need. One is if I have cosine squared of theta, I can write it as half of 1 plus cosine 2 theta. If I have sine squared theta, I can write it as half of 1 minus cosine 2 theta. Okay? Yeah. Yeah, usually this is the way we need them often, okay? So these 2 are often used in this form, okay? You don't replace you use these 2 identities in order to reduce the exponent. So you notice that the exponent here is 2, but the exponent here is 1. However, the angle has been doubled, right? Yeah, you could, but I'm saying you wouldn't usually do that. The reason is that whenever you use these 2 identities, your goal is to reduce the exponent, and so you wouldn't be using those. See, the goal is you're writing cosine squared in this way. Why would you go back to cosine squared? Am I making sense? So usually you don't do that. Yeah.
Now, for the second one, can you do it in reverse? Can you, like, so say you have the cosine theta minus sine squared theta, or cosine squared theta minus sine squared theta. Mm-hmm. Can you convert that to cosine? Okay.
So you can write it as 2 cosine squared minus 1. And that's where you're getting this one from, actually.
Okay. Oh, okay. That makes sense.
Yeah. Okay. What else do we need? We also need to know the following. Usually, I don't want to say it, but I'll say it. Usually, you need these 2 in Calc 2 and in Calc 3 because these 2 are used to evaluate integrals involving these trig functions. But we'll see that later. And then there are 2 others which are the following. If I have cosine of A and sine of B, that's the same as half of you know what, let me write switch A and B. I don't have to really, but I'm going to I'm going to rewrite this in a little bit differently. Sine A cosine B. It doesn't really matter. All I did is I switched A and B, right? Half of sine of A minus B plus sine of A plus B. Okay, so sine A cosine B is the same as this. So what did we do here? Sometimes in some problems, you need to be able to, you don't like the product here. You have the product of sine A and cosine B. And in some problem, you cannot work with the product, so you need to rewrite this so that you don't have product of sine and cosine anymore. Okay. Same way, if I have cosine A, cosine B, that can be written as half of cosine A minus B plus cosine A plus B. Okay, so one of them is in terms of cosine and the other one is in terms of sine. Okay, I think this is it. These are the all identities that we need to know. Now, in my handout, I think in one of the pages, well, remember the first handout that I gave you on trigonometry? In that handout, wasn't there a page on just identities? All the identities were written on it, right? So those are the ones that you need to know. And then in my trigonometry cheat sheet, you'll see that you have you have many other things there that I didn't go over. Okay, and the things that I didn't go over there, you don't need them. But everything that all the identities that I gave you, they are there. Okay, so you might want to mark the ones that I mentioned in the class, and those are the ones that you need. Okay. All right. So what I want to do now is go do a couple of examples, and which will help you with your homework. So in terms of knowing facts about trigonometry, we are done. We know most of the facts now. All I need to know are what are the graphs of these functions. So we'll see those later. Example, suppose that if cosine of an angle x is negative 1/3, don't see, one of the reasons math is sometimes confusing is all these symbols, they are used to mean different things at different times, right? So I have been using x and y for denoting coordinates of the point P, right? Now I'm saying x is an angle, right? Cosine of x, so x is an angle here. So cosine x is negative 1/3, and x is between pi and 3 pi over 2. And the question is find the remaining trig ratios. Is that making sense? So it means that I want to know what is sine of x, what is tangent of x, and so on. So how would I do it? Anyone? How would I do it? What's that? Okay, so what you're trying to say, let me make a picture to demonstrate that. I don't need, I can do the problem without using the picture, but it helps, yeah. Yeah, so what he's saying, let me explain to you all what he's saying. So here's my x and y axis. I know the angle x is between what? Pi and 3 pi over 2, which means it's what quadrant? So I call this the first quadrant, second quadrant, third quadrant, fourth quadrant. Pi and pi over 2, that's the third quadrant. So my angle x, the terminal side is right here, right? So my angle x, again, the angle x is the angle here, okay? It's an angle between pi and 3 pi over 2. So that's the position of the angle. So then, from the intersection of the terminal side and the circle, if I make a vertical line onto the x-axis, notice that I'm not saying this is a unit circle, okay? I'm not saying this is a unit circle yet. So now, so what do we know? We know that cosine of x is what? Cosine of x is given to be a negative 1/3, right? Negative 1/3. So that tells you that the adjacent is what? Negative 1. The hypotenuse is 3, as you said, because cosine of x is negative 1/3. I can take the adjacent to be negative 1. The hypotenuse is 3. Remember, hypotenuse is always positive, okay? So now, from this now, can you tell me what is sine x? Well, before I even go there, I need to know the length of the opposite, right? So what is the length of this side? What's the length of the opposite? I have to use Pythagorean Theorem, right? So what is that? So it will be the square of the hypotenuse minus the square of the adjacent, right? What is that? 9 minus 1, right? Square of negative 1 is 1, right? Square of negative 1. Square of negative 1 is positive 1. Negative 1 times negative 1 is positive 1. So 9 minus 1 is 8, right? So and then I have to take the square root of that, right? So you guys are okay with that? So what I'm saying is that this side here, let's call that a. Then I'm saying a squared plus negative 1 squared is 3 squared, right? So then what is a? It will be 9 minus 1. So a would be root of 8, right? So this side is root of 8. Can you write root of 8 as 8 is 4 times 2, right? So root of 8 is the same as 4 times 2, root of that. So isn't that then root of 4, root of 2? Root of 4, root of 2, which is 2 root 2, right? So can I say that sine x is what then? The opposite over the hypotenuse 3, right? Okay, what is tangent? Yep, very good. So the opposite over the adjacent. And adjacent was negative 1, right? And that's just the same as negative 2 root 2. Wait a minute. We made I made a mistake here, right? Didn't I? When I said the length of a, I shouldn't be taking it positive, right? It should be negative. Sorry. A is negative root 8. Sorry. So a is whoops. A is negative root 8, right? Because it's a negative. It's on the point P. The point is the intersection of the terminal side and the circle is in the third quadrant, right? So the opposite is negative. Okay, so it's negative root 8, not positive root 8. When I'm applying, I shouldn't have said negative 1 here. I should be saying, if I'm applying the Pythagorean theorem for that right triangle, one side is 1, the other side is a, the other side is 3. Okay, so from that I know the value of a should be root of 8, but only if I'm looking at the triangle as just positive sides. But then when I put that in my circle, I have to write negative root 8. You guys are okay? Alright, so now this would be negative, this by this would be positive. Is everybody okay with that now? Okay, how about secant x? Secant x is hypotenuse over the adjacent, right? So this would be negative. This would be 3 divided by negative 1, which would be negative 3. And the last one is what? Cosecant x. Say it again. Cosecant of x would be the hypotenuse 3 divided by the opposite, which is negative 2 root 2, which is the same as negative 3 over 2 root 2. Everybody's okay with that?
So the sine is negative, right?
Just say it again.
The sine is negative.
Oh, the sign was negative, yes. It will be negative root 2 over 2 divided by 3, yes. Generally, in the first quadrant, all the trig values are positive. In the first quadrant, if you have an angle in the first quadrant, then all the trig values are positive. In the second quadrant, sine and cosecant are positive. In the second quadrant, if you have an angle in the second quadrant, the sine and cosecant are positive, everything else will be negative. In the third quadrant, only tangent and cotangent are positive, everything else will be negative. Always, okay? If you have an angle in the fourth quadrant, then cosine and secant are positive, everything else will be negative. Is that making sense? Okay. All right. Say it again. Oh, I didn't do cotangent. Oh yeah, I didn't do cotangent yet. So cotangent, it will be adjacent over opposite. So this would be negative 1 over negative 2 root 2. So this would be the reciprocal of tangent, right? The reciprocal of tangent. All right, sometimes, yeah. You're talking about right here? Okay, so I have root 8, right? So root 8 is the same as root of 4 times 2, because 8 is 4 times 2. And then root of 4 times 2 is the same as root of 4 times root of 2. And then root of 4 is 2, and the root of 2 is the same as root of 2. You're asking about this question, right? Oh, how did I get negative root 8? Okay, first of all, we are trying to determine the coordinates of this point here, right? Now notice that the coordinates of this point would be both negative because it's in the third quadrant, right? And now when I am applying the Pythagorean theorem, I am looking at this right triangle, but when I'm applying the Pythagorean theorem, I'm assuming all the lengths are positive in order to find the length of this side. After I apply the Pythagorean theorem, I get root 8, but then when I look at the coordinate of this point, I have to write negative root 8. So when I apply the Pythagorean theorem, I'm taking all the sides to be positive. But then when I translate that as the coordinate, I'm making it negative. Yes. Any other questions? Yeah.
The magnitude or the hypotenuse is always magnitude, right?
Yeah, the hypotenuse is always positive. Hypotenuse is always positive. Any other questions? Okay. Now, sometimes in some problems later on, you need to solve equations involving the trig functions. Okay. So here is an example of that. So sometimes you might have a situation where you need to solve an equation like this. Let's say I have to solve 2 times sine squared x equals to 1. So let's say this is what I need to solve. Is everybody okay with that? All right, so then from here I get, in order to solve it, I'm going to say, well, this is sine squared x is equal to half, right? And then what can I say about sine x? What can I say about sine x? Yeah, it'll be root of 1/2, right? Plus or minus, right? So it's either plus 1 over root 2. If you take the root of 1 over 2, you get 1 over root 2, right? And then or it's sine x is negative 1 over root 2. Is everybody okay? All right, so now what can you say about x? You're trying to solve this. Now, can somebody tell me, give me the value of x between 0 and 2 pi? Why do I care only between 0 and 2 pi? Because once I get all the angles between 0 and 2 pi for which sine x is 1 over root 2, then what are the other values? Well, you just add a multiple of 2 pi. Am I making sense? So give me all the angles between 0 and 2 pi for which sine is 1 over root 2. 1 over root 2 is the same as root 2 over 2, right? So between 0 and 2 pi, between 0 and 360, right, degrees, for what angles do you get sine to be root 2 over 2? So for this one, x is what? Pi over 4 is one of them. At pi over 4, look at the circle that I gave you, right? The circle handout that I gave you. Yeah, when x is pi over 4, sine x is root 2 over 2. Also when x is 3 pi over 4, right? In the second quadrant. And that's it, right? Between 0 and 2 pi, these are the only two angles for which sine x is root 2 over 2. Okay? Yeah?
I feel like I missed a step in between
Right here?
Come up with the sine x, yeah.
Oh, I'm taking the square root. I'm taking the square root of both sides. You
Oh,
get
okay.
Plus or minus the root of half.
Okay.
Yeah.
Thanks.
How about this one? What is x? What are the possible values of x there? 5 pi over 4, and what else? 5 pi over 4 and 7 pi over 4. You guys agree with that? Again, look at the circle. Values. We are looking at the circle handout.
Yeah.
And you look at the coordinates, right? You'll see that, look at the coordinates where the second coordinate is negative root 2 over 2. See, this is the same as negative root 2 over 2, right? And so find out the points where the second coordinate is root 2 over 2. There should be 2 points where this, and 7 pi over 4, right? Those are the angles for which the second coordinates are negative root 2 over 2. So those are the angles where sine is negative root 2 over 2. Okay. Okay, so these are the angles between 0 and 2 pi for which the equation holds, right? These are the solutions between 0 and 2 pi. How about other angles? How about angles beyond that interval from 0 to 2 pi? Well, all you have to do is add a multiple of 2 pi for each of your answers. So if I want to know all the solutions or all the values of x that satisfy this equation, all I have to do is add a multiple of 2 pi. Am I making sense? Because when you add a multiple of 2 pi, if you add a multiple of 2 pi with pi over 4, you always come back to the same place, right? Come back to the same place. So these are the solutions between 0 and 2 pi, but other solutions are given by what? So other solutions are would be pi over 4 plus or minus, I don't even need plus or minus, sorry, plus 2 times n times pi, where n is an integer. It's a multiple of 2 pi. So n is an integer. 3 pi over 4 plus 2n pi. The same way, 5 pi over 4 plus 2n pi. 7 pi over 4 plus 2n pi. Okay, again here n is an integer, okay? N is an integer. Have I used that symbol before? Maybe I didn't. Okay, let me not use that symbol then. N is 0, plus or minus 1, plus or minus 2,